Hello and welcome to the epic data duel you never knew you needed. In this session, you've likely heard two heavyweight acronyms tossed around, ETL and ELT. In this section, we'll break down both processes, follow their evolution, and underscore why grasping their differences is crucial, especially as AI development demands ever-scaling data operations. Picking the right approach has enormous impact on an organization's data roadmap, shaping scalability, efficiency, and how accessible data becomes. The evolution from ETL to ELT reflects the shift from traditional business intelligence systems to more flexible architectures that support big data. While ETL remains an essential framework, ELT has emerged as a response to the growing complexity and velocity of data-driven decision-making processes. So the ETL process, time sink or time saver. Prepping data is often the most tedious part of any analytics flow or AI pipeline. This involves fetching, cleansing, and reshaping data so it's fit for purpose. ETL, which stands for extract, transform, and load, is the traditional way to get this done. First, you extract data from multiple sources, databases, APIs, scheduled file transfers, whatever your business relies on. Then, before that data even touches your warehouse, it goes through transformation. This is where calculations, standardizations, and aggregations happen in a separate staging area. Finally, once the data is cleaned up and structured, it's loaded into the data warehouse, where it's finally ready for analysis or training machine learning models. For years, data engineers have relied on structured playbooks like UML, Unified Modeling Language, BPMN, Business Process Model and Notation, and ontology-based designs to keep data flowing in a predictable, step-by-step fashion. These approaches brought order to the chaos of early data pipelines, but let's be real, they were built for a slower, more structured world. Today's AI and big data environment demands speed, adaptability, and the ability to handle messy, unstructured data without missing a beat. However, these approaches often struggle to adapt to the speed and complexity of modern AI-driven data environments where real-time decision-making and unstructured data processing are key challenges. So, traditional ETL frameworks often fall short, bogged down by inefficiencies in transformation logic and an inability to handle unstructured data seamlessly. Okay, so what about the ELT process? Is your warehouse smarter than you think? ELT flips the script by rearranging the order of operations. Instead of transforming data before it enters the warehouse, ELT, extract, load, transform, takes a different approach. Raw data is loaded straight into the warehouse first, and only then does transformation take place. First, data is extracted from multiple systems, just like an ETL, but instead of stopping for cleanup, that data is loaded directly into the warehouse in its raw state. Only after it lands does transformation occur, using the processing power of the warehouse itself. This approach aligns perfectly with modern cloud-based architectures. With tools like Snowflake and BigQuery, ELT enables near instant access to raw data while eliminating the need for separate transformation servers. it also solves an old problem in ETL workflows: semantic heterogeneity. This refers to inconsistencies in how data is structured across different sources, something ELT can handle more efficiently since all transformations happen in one centralized location. So let's talk more about the shift from ETL to ELT. Farewell, old guard, hello, future. Back in the day, setting up a data warehouse was a massive investment. It required expensive hardware, software, and licensing, which meant only the most refined, aggregated data made it in. That made ETL the dominant method for decades. But businesses today need agile, scalable architectures. This demand led to the rise of new modeling paradigms, UML-based frameworks, ontology-driven systems, and model-driven architectures, MDA. ELT emerged as a natural evolution designed to address the limitations of traditional ETL, particularly when it comes to handling real-time data streams and eliminating transformation bottlenecks. Plot twist. The warehouse strikes back. Let's talk about the evolution of data warehousing. By the 2010s, 3 game-changing shifts made ELT the new standard. First, cloud-based data warehouses like BigQuery, Redshift, and Snowflake became more accessible, eliminating storage constraints and introducing built-in processing power. Next, the explosion of big data, structured, semi-structured, and unstructured, made traditional ETL pipelines struggle to keep up. Finally, agile and lean methodologies took over, and businesses needed immediate access to raw data. The rigid waterfall-style approach of ETL no longer made sense. Newer ETL modeling methods now incorporate incremental data updates, metadata-driven processing, and automation to adapt to this fast-paced landscape. Modern frameworks need to support both traditional batch jobs and real-time data streams, ensuring flexibility across different use cases. So let's talk about the advantages of ELT over ETL. ELT is becoming the go-to choice for a reason. Cloud-based warehouses take on the heavy lifting, reducing processing bottlenecks. Analysts and data teams can work with raw data, shaping it as needed without waiting on predefined transformation rules. And when your data sets scale to petabytes, ELT ensures that data remains flexible, efficient, and ready for advanced analytics and AI applications. With ELT, there's also a major win for scalability. The ability to store raw data means teams can go back and reprocess it differently whenever needed, an impossible feat in traditional ETL systems that discard unstructured data early in the pipeline. This makes ELT a better fit for machine learning, as models can tap directly into raw unprocessed data with minimal delay. So let's talk about DAGs, why DAGs matter in your data workflows. At the core of ELT's efficiency is something called a directed acyclic graph, DAG. Simply put, a DAG is like a roadmap for your data pipeline, ensuring every transformation happens in the right order. Imagine you're cooking a complex dish. You can't bake the cake before mixing the ingredients, right? DAGs work the same way. They define dependencies between tasks, making sure each step in the transformation process waits for the necessary preceding steps to finish before moving forward. In ETL and ELT, DAGs ensure that data moves in a structured, logical sequence, preventing errors like missing dependencies or incomplete transformations. For AI models, this is critical. One misstep in the data pipeline can lead to outdated or inaccurate predictions. Okay, so a quick rundown of the best ETL and ELT tools for your data pipeline. As ETL and ELT have evolved, so have the tools supporting them. If you are working in a traditional ETL setup, tools like Apache Airflow, Talend Open Studio, IBM Infosphere, and AWS Glue might be your go-to options. But if you're moving toward ELT, tools like Fivetran, Airbyte, Matillion, and DBT, Data Build Tool, offer seamless integration with modern cloud data warehouses. Okay, so some final takeaways. Why your AI pipeline needs ELT. If your AI models are underperforming, your data pipeline is probably the culprit. ETLs is slow, rigid processing is outdated in today's fast-paced AI-driven world. ELT, on the other hand, provides the flexibility needed for real-time workflows, with DAG-based orchestration keeping your transformations in check and incremental updates reducing processing costs. ELT is the way forward. If you want to future-proof your AI and analytics, it's time to ditch ETL and embrace the ELT revolution.